Yeah, good morning, sir. In the last video, in this workshop, okay, seminar. So, regarding this data structures and algorithms, in the last videos, just we had a casual discussion about what is mean by algorithm. So, what things are required to prepare algorithm, and what is mean by flow chart, and we created a sample algorithm, and even we implemented that algorithm, and even we have seen flow chart for that algorithm. After this, we have seen what is mean by data structure, what are the common operations that we can able to perform on data structures, and even have you observed here? So linear and non-linear, there are two categories of data structures are there. That part also we explored. And syllabus for this course also we have seen very clearly. And what are the new upcoming batches also we have listed. Okay. Then, sir, we have some 10 algorithms. Our main agenda for this seminar is nothing but we need to prepare a program, or we need to implement algorithms, sir, to solve these 10 problems. Okay. What are the various approaches are there? That part we are discussing now, right? So as a part of this, we covered very clearly about how we can able to perform addition of two numbers, and even we had a discussion about how to calculate a maximum of two numbers. Sir, even we discussed about maximum of three numbers. So even we had a discussion about how to swap given two integers. How many logics I covered, sir? I think four logics. There is one more logic is there, sir, by using bitwise operators. Okay. By using bitwise operators also, we can solve this. So how you can able to solve this, we will discuss now. Just please wait 1 minute. Yeah, right. So by using bitwise operators, how you can able to solve, we will discuss now. Okay. Sir, what are the bitwise operators we are using here is A is equal to, sir, A cap B. Okay. B is equal to A cap B. Again, A is equal to A cap B. Like this we are using. This is the bitwise operators style by using which we can implement. Sir, I will explain this logic very clearly. Okay. So have a look. So what is that? What is that logic, sir? By using So bitwise operators. Okay, by using bitwise operators, how we can able to. So let's have a look on this. A is equal to A cap B. So B is equal to A cap B. Again, A is equal to A cap B. Like this, I'm taking. I want to demonstrate this, how it is going to work. So let me consider the way a value of A is equal to 2. Okay. Otherwise, the value of A is equal to 3 and the value of B is equal to something like 9 I want to take. Okay. Sir, before swapping, the values are nothing but 3 and 9. So we have to perform swapping and we need to see the result. But make sure that bitwise operators so will work only on binary numbers. So if you take the number called A is equal to 3, you have to convert this into binary. We know, right? 8421 code. Sir, 8421. This is nothing but binary equivalent for the number 3. And if you take B is equal to 9. Okay. Sir, here 84. So 21. This is nothing but binary equivalent for the number 9. Sir, cap means what? What is a truth table of cap? If 1 and 0 is there or 0 and 1 is there, in these two cases, the result is 1. Sir, if you take 0 comma 0 or if you take 1 comma 1, the result what we are going to get is nothing but 0. So based on this, sir, what is the value of A? A is equal to, we are doing A cap B. Sir, 0, 1, you will get 1. 0, 0, you will get 0. Sir, 1, 0, you will get 1. 1, 1, you will get 0. Right? So this equivalent value is nothing but 1, 0, 1, 0. Sir, next B is equal to A cap. What is the latest value of A? Sir, 1, 0, 1, 0. Sir, what is the latest value of B? 1001. Right? So this value we have to check. Sir, 1, 1 means you will get 0. 0, 0 means you will get 0. 1, 0 means you will get 1. 0, 1 means you will get 1. This is the latest value. Sir, we have last instruction is there, right? A is equal to A cap B. Sir, 1, 0, it will become 1. Sir, 0, 0, it will become 0. 1, 1, it will become 0. Sir, 0, 1, it will become 1. Have you observed what is its binary decimal equivalent? Sir, it is nothing but 9. What is its decimal equivalent? It is nothing but 3. Sir, is the values got interchanged or not? Previously, B value is 9. Now, A value is 9. Previously, A value is 3. Now, B value is 3. Like this, we can able to interchange. Sir, hope you people got a clarity how this algorithm is going to work, right? Clear, sir? Everyone, please confirm so that I will implement by using a simple program. Clear up to this? Santosh, you have to understand this binary conversion because it is a programming basic level concept, man. Okay. So if you take any number, for example, 7, so how you can able to convert? You have to divide with it. Okay. How you are going to get that? If you divide with the 2, so 2, 6, 2, 2 3s are 6. Remainder is 1. Okay. Sir, 2 2s are remainder is nothing but 1. Okay. Sir, 2 1s are 2 remainder is 0. So 1 0 1 1 is the decimal binary equivalent for the number 7. But for that we have a shortcut is there like 8421 code. Clear, Santosh? Right. So let us implement these programs. So whatever concept we have covered in the previous, same program, there is no change in this program. Same program as it is, we have to check, sir, but the only difference is nothing but we have to write that logic. So static, better I will copy paste. So the only thing what we have to do here is, sir, swap 5, which is going to receive two values like A and B, and sir, to swap A and B values, which logic we are using? So by using, so bitwise operators. Okay. Sir, what will be the instructions? A is equal to A cap B. As a programmer, we are not required to convert to binary. Automatically it will turn. Okay. Sir, then B is equal to A cap B. Then A is equal to A cap B. Like this it will do. So if you want to call this, how to call? Sir, just system dot out dot so println I am taking. Okay. So and then I am going to call demo dot swap 5 of A comma B. That's all. So let us compile this code first of all. So cd backslash cd Prakash classes. So Java C. So test.java I'm taking. So Java space test. Sir, it is asking enter a value 3, 4. Sir, last logic you have to observe. Why? Because the previous logics already we have seen, right? So just we need to concentrate on last logic. Sir, what is the last logic here? So before swapping A is equal to 3 and B is equal to 4. After swapping A is equal to 4 and B is equal to 3. So the values got interchanged or not? Yes. So this is nothing but, sir, what is the program that we have for this purpose? Okay. And let me copy paste output also. Can you please confirm, is this concept is clear for everyone? Right, sir. So anyway, the people who are interested to continue this batch, I mean continue to attend these classes, sir, you can register for the course and you can continue. And these are the information regarding the batch details. Okay. Yeah, this is nothing but the information regarding batch details. And if you want rest of the programs, the videos are already existed, you can watch. Okay. So this is the syllabus what we are going to discuss, like introduction, problem solving, time and space complexities, notations, different aspects of algorithms and examples of algorithms, mathematical algorithms, bitwise operations, recursion, arrays, matrix, searching and sorting, linked list, stacks, queues, binary trees, hash tables, hashing, AVL trees, dictionaries, graph, greedy method, backtracking, dynamic programming, like n number of things we are going to discuss. Okay. Yeah. So the people who are interested to continue, okay. So the batch will be started from tomorrow. Already demos got completed. So if you can join and you can purchase the previous class videos will be given. Okay. So you can continue from that. Okay. Right. Thank you, sir.